All right, guys, welcome to Pre-Calculus. This is 411, and we're going to be talking about uh, graphs of polynomials, and especially when they're in factored form, and how we can go from factored form to a graph and vice versa. So for day one, we're going to be taking a look at this. So problem one, there's 10 different equations here. So what I want you to do is open up a tab for Desmos, and then you're going to pick a value for A, a value for B, and a value for C. Go ahead and make either A or B negative, and then the other one positive. And then C, let's just make that always positive. Once you determine what you want, go ahead and graph F, then graph G, then H, then J, then K, then L, then M, then N, then P, then Q, and so forth, right? So graph all of those. And when you're doing that, what I want you to do is, one, take a look for any patterns, things which they see that are happening. Then go ahead and sketch each of those graphs, just like a quick little sketch about what's important in its shape. Then tell me what the degree of the polynomial is. So again, that's if you multiplied all of it out, what would be the largest power of x? And then say what any of the x-intercepts are. Don't really worry about y-intercepts, just the x-intercepts. And then lastly, the end behavior. Now, I don't care about you using the book's kind of terminology here for as x values increase, the y values do this, right? Just say, hey, as it goes far to the right, it goes up, and far to the left, it goes down, or vice versa, or whatever it happens to be there. So do that for all of those. Then once you are finished, go ahead and come back here, and we'll talk about what you should have hopefully noticed doing that. Okay, so what we hopefully notice is a few things. The first thing is going to be dealing with how those things cross the intercepts. If it was a binomial raised to a first power, you would cross that intercept by just going straight through it, right? Just as you normally would, and as you've seen. If it was raised to the second power, we would see that it always just goes and just touches the axis at that particular point. And then if it was raised to the third power, it would cross through it but kind of wiggle. And then like a fourth power would again touch it, but it touches it at a bit more of a boxy way. And then a fifth power is going to wiggle through it, but it wiggles in more of a boxy way. Effectively, as you get higher and higher powers, it just becomes more and more boxy, for lack of a better term. But you hopefully see the pattern of everything. If it's a binomial being raised to an even power, it'll just touch there. If it is being raised to an odd power, it'll cross through it, but the more powers you add, the more it kind of wiggles through it, or stuff like that. Then end behavior was the other big one there. So the end behavior, if it was an even degree, it was always up and up, or if it was negative in front, it was down and down. If it was odd, you would be up on the right and down on the left. And then if it was negative and odd, it would be flipped. So it would be up on the left and down on the right. So if you kind of get those things down, then you're going to be able to try and graph these with just me giving you, hey, here's the polynomial in factored form. Give me a quick sketch of what this would look like. And that's where we're going to be going for next time in day 2 of this. So homework-wise, I'm just going to be doing 6 through 13. So go ahead and work on that. And then tomorrow we're going to be taking this and trying it out a little bit more, right? Talk to you guys next time.